My name is Kristian Dupont, and I am head of engineering in a company called MyMe, which is a health tech company. We help people with autoimmune diseases get better. So the way it works is that you get a coach, and then you get an app, and you have calls with your coach once every week or so, and you track on your app what your symptoms are and what you're doing to try and help alleviate these symptoms. So one of the groups of people we're helping right now is people who are suffering from long-haul COVID, which is a lot of people. They tend to get very tired, they get brain fog, and they have headaches and stuff like that. And we help them get better by figuring out that if they, for instance, have a trigger from sugar, then we can see in their data, okay, it looks like every time you've had excess sugar, you get really tired the next day. And those are the kind of things that we do. So MyMe is a mobile app, obviously, but it's also 2 web apps that we're using. So one is for the members and one is for our coaches. So those are the 2 things. And we have one backend that serves all of this. I also have my own personal little startup called Submotion, which helps you manage SaaS subscriptions. Which is not really relevant tonight, other than I'm also using this for that. So I kind of speak into capacities here. I'm thankful to Sem for allowing me to speak about this because it's not really a React specific thing, but it does apply to React. And I promise I'll tell you how we are using it in React because I think it's quite interesting, but it's also very interesting on its own. tRPC. RPC stands for Remote Procedure Call. I'm actually not completely sure what the T is for. It might be TypeScript, or maybe it's typed, or maybe it's something else. But it's a way to make calls from a front end to a back end, or from a mobile app to a back end. It's basically, let me see if I can figure out how to go to the next slide. It's basically related to this thing that we always refer to as APIs. And I think when I think of what an API is, it means to me, I think of mostly something that is accessible to third parties. So it's the interface that I expose if somebody in a different company or a different group of people in the same company maybe, but like a different team or something, needs to access something that I'm exposing to the world. So I'm making an interface available to somebody else that they can access it. And that needs authentication, that needs security, that needs conventions and all those things. And when we're doing that, we should use GraphQL or we should use REST. And that's what we almost all do. If some of you have been developing for a long time, you may have been using SOAP or other Java, Microsoft-y ugly things that were like a horrible XML mess that nobody wants to use anymore. But REST is like the big winner, and then GraphQL is what is coming out and seems to be gaining a lot of traction. But I think when we're doing something internally, I don't know that these are the best ways to think of connecting a front end to a back end. And that is especially if we're like a team of just a few developers, like we are in MyMe. We're making a big effort to be a small team that is no silos. So there's no back-end, front-end team. We're one team of full-stack developers. And I know that's a little bit controversial to some. There are some that say that no such thing as a good full-stack developer exists. I do feel like that's not true. I feel like it is working quite well for us, but it's definitely something that some people are uncomfortable with, and some people like to develop more backend stuff than front end, and vice versa. And that's perfectly fine, but I do think there's a big strength in having both for everybody, so that we never have these bottlenecks where we say, well, I can't do this right now because I don't have this endpoint. And you have to go and talk to the backend team, and you have to go to into their Scrum process and whatever before that can work. And then so we come back and this whole thing. I really want to avoid that, so I wanted to have a one glued together team that is small, that can work really rapidly. And I think a lot of people still end up creating REST or GraphQL because that's just what we do when we have a server. But if we try and look into how does REST work and what is it really? One tweet I saw recently that I think is quite fun is that it's very hard to define exactly what REST is, like, and people argue a lot whether something is true REST or if it's really good, done the right way, very virtuous. If any of you know about the abbreviation HATOS, or I don't know how to pronounce it, but yeah, hypertext. I forget what it's short for, but there's like this virtual thing, like this is the way you should design a REST API, and people argue a lot about when is it good REST. So REST has a bunch of it imposes a bunch of limitations on the way you write your code, right? We write an endpoint and we say, what is the verb that we're using here? Is it post or get, or is it put or patch or delete or all of those things? And then we have a path that is a path to a resource. And then the idea is that you modify this resource with the verb that you declared, that's great. Like sometimes limitations can be a really, really good factor for building creativity. Like we all know that if you have a blank canvas of sorts, it can be really intimidating. But if there's something already that you are improving on, your brain sort of works in a much more effective way. But I also think that it can be in many situations it can build really strong architecture. And one example is immutability that a lot of us use. And since this is a React group, probably everybody here is familiar with immutability, which used to be more of an academic thing that they were talking about when like Haskell developers and all the functional people and stuff, they knew about it, but otherwise it was pretty much in academia. But now everybody's really using it because it's proven that, yeah, well, it's sort of a limitation. It means that I have this variable and I'm not allowed to change it. I'm only allowed to make a copy of it that has different characteristics. That is positive because it enforces an architecture that just happens to work much better with concurrency and with just a number of different patterns that we use that just helps. I wrote this blog post called "Mutable State is to Software as moving parts are to hardware," because I think it's sort of that. Like you have if you have an MP3 player, it's much more reliable than a CD player that has a spinning disk and all those things. But of course, there are situations where you need the moving parts, so you can't just always avoid them. However, it's not clear to me that the limitations that REST pose on us are very helpful. None of us think about resources and verbs in the code that we otherwise write. At least I don't, and I've never seen it. So I don't know if any of you have seen that. It's not we think of like our entities in our database, if we have one of those, and like our entities in memory, but we don't think I'm going to put this or I'm going to patch it. And what is the difference? Or is it in like what is the operation I'm working on here? And it also has this thing when like a resource is supposed to be one thing, and I think we've all tried making a REST endpoint, and it needs to join two things. Like this is both a member and their accounts or something. Is it the member that is the resource I'm looking at here, or is it the accounts? And then do I specify this as a query parameter, or like it gets a little bit weird, and it's sort of like not really made for that. And that's a problem we don't ever have when we write our normal code. Also this, when we make a REST server, at least if we make it in Node.js, there's probably a bunch of alternatives, but if we use the normal Node.js ecosystem, there's no type safety and there's no validation out of the box. We can add Swagger, which helps us do this, but then we need to update definitions in JSON to keep everything up to date. And that is not directly connected to our code. So we need to maintain two sources of truth now, which is really annoying and often goes bad. So then people are looking towards GraphQL. GraphQL is, I think, very interesting and very promising, and I think it's a very, very nice tool for public APIs. For instance, GitHub exposes a GraphQL API that is much nicer to use than their REST API. And I should make the disclaimer here that I've only ever consumed GraphQL APIs, so I don't know as a producer of one what it's like to work with. I do think that it's great. I think GraphQL has two main concepts, which is queries and mutations. And those are pretty much like what we think of as functions and procedures, which procedures is not all of the C-derived languages don't talk about procedures, but that just means a function that doesn't return a value, it just does something, and that's pretty much what a mutation is. It's like go and do something that changes something. I think that's very nice in GraphQL, but it has a bunch of downsides as well. It introduces new tooling and plumbing, which is just not nice if you can avoid it, but I mean, we can probably live with that. It also introduces a new language, which I personally think is annoying because there's plenty of languages there already. And like there's one big query language that we're all using called SQL. And okay, now I have to learn this other query language because we want something different on the front end. That is a source of annoyance, but probably also worth it. And then GraphQL has some known issues with caching. And the good people of Apollo, who are making a big GraphQL thing, they talk a lot about it. I have a number of blog posts about how that's actually not really a problem, and maybe it isn't. But the thing is, GraphQL requests are always post requests, which means that they're not per default in HTTP being cached. So you have to add layers on top of that for proper caching, and that can create some issues. My biggest issue with GraphQL for using it internally in a coherent team like the one I'm trying to build is that I think when you are exposing an endpoint that is GraphQL, you're sort of encouraging people to make something that will work with all kinds of parameters because it's a query. Like it's like, let me know what all of the parameters I should take, and because it's a query, it's sort of I don't know. I just feel like there's something in it that sort of nudges you towards making functions that can do everything, like queries that can do a lot of things, which I don't know is a very nice trait. It's probably not a big problem. It's just something that irks me a little bit the wrong way. Not that that should be a deal breaker to anybody, but the thing was that I discovered this thing called tRPC recently, and I've been very excited about it. And it's new for me. So we've been using it now in MyMe for 2.5 months, and I'm slowly introducing it in my own startup thing. So it's with that amount of experience. So there may very well be, I may be giving a talk in a year saying, never ever use this because it turns out that it doesn't work at scale or whatever. But so far, I've been quite excited about it. So this was designed by a guy named Colin something that who is a little bit famous in TypeScript land. He wrote a validator called Zod that some of you maybe have seen or used. So he wrote this as a proof of concept, and then this Swedish guy that I forget his name, he goes as Kat, K-A-T-T. He took it over and turned it into like a more of a product, and it's, despite its young age, I would say it seems quite mature, and so far, well, I'll get back to what the kind of challenges we have with it. But basically, it's something similar to GraphQL somewhat. It's still plain HTTP, so it's not. When you hear the word procedure call, remote procedure call, you might be thinking of binary like protobufs or something. Right? There's a bunch of procedure call protocols that that are much more sort of scary and meant for embedded devices or all that stuff. But this is just HTTP. You can expect it in your web dev tools, and it's very easy to work with. As that everything is encoded as JSON unless you ask it to do something else. And you still have queries and mutations. And this here, it's more of just a mental distinction, because basically it doesn't really mean anything. It's just a way for you to just divide things, saying, okay, this is a query because it's something that returns something, or it's a mutation because it mutates something in a database or something. But you don't actually really have to do it. But queries here are encoded as GET requests. So the parameters are query parameters, and that means that all the HTTP caching that we rely on, which is also, by the way, sitting in all kinds of like load balancers and the CDNs and like all of that infrastructure on the internet, which is like nice that we know that that just works optimally. So that is there, and the reason why that is possible is that you just make a call with few parameters here. It's not a query that needs to be encoded like a big thing. But that's at least how it is for now. There's work being done on WebSockets that we are not using yet. It might be mature enough to be used, but I can't speak to that. Then it makes it very easy to add the runtime validation using, for instance, SOD. So that's clearly what the guy had in mind when he wrote it, because it almost feels like that just clicks in, but it is something you had to add yourself. So it's not batteries included, so to speak. And the same for encoding stuff. This is SuperJSON is a library that's new to me, but it turned out to be very nice. So that will basically take a JSON object or a JavaScript object and turn it into two JSON objects, one which describes the values and another one which describes some metadata, which means that you can now send, for instance, a date, or you can send undefined, which are two things that aren't supported in JSON, which I have personally experienced weirdness with, because it just turns into strings, then you send them, and then you hope that your front end understands that date string. And there's a few things there. So you can easily add something like SuperJSON, which handles that. And it looks like this. I hope this is big enough. Can everybody see? This is a screenshot, so I can't zoom, but I hope it's visible. One thing that's missing here at the top is a create router call. But I can try and show you a little bit in my IDE in a minute. But basically, this defines a query on the back end. And so this query takes an input that has, so this is an endpoint called get profile, and this is just an example. It takes an ID, which is a number, and then get extended info, which is a Boolean. So sort of like a function. And then you can see that the resolve function, which is what you supply it with here, it takes this input parameter, and that will automatically have those values that we specified above. And this is being validated by TypeScript, so I get autocomplete and I get squiggly lines underneath if I try to access something that doesn't exist. And then the logic in here is not that interesting. You can see that if I don't find a user, I will throw a specific error instance called tRPC error. You don't have to use those, but they just sort of add a little bit of metadata that you can use, but you basically just throw an exception if something goes wrong. And then here at the bottom, I return this object here. So it has an ID and a first name and a last name, and an optional profile picture if you ask me to get the extended info. So this is the return value from this query, and that up there is the input. And when I then on my front end start to write code that uses this endpoint, by pure magic, I can write this, and you can see I type profile equals to, so I await my tRPC client. I call this query that I just specified. I give it an ID and this other parameter, and I get autocomplete on those and squiggly lines if it is misspelled. And then the output will have these properties that it knows from there. which is just to me amazing. I didn't write that anywhere else. And so I have TypeScript checking at compile time that I'm not specifying something that doesn't exist, or mistyping something, or expecting something to be a string when it was actually a date. So that is worth it all to me. And there's no compilation step or anything involved in this. It just works immediately. And the way it works is by using a little sort of trick or hack, if you will, in TypeScript, which is that you can import a type. So this is a normal import statement, but in TypeScript you can also import just the type, which you specify by just adding type after import, and then you can specify something that can be anywhere on your hard drive. If you import any regular code, so to speak, that isn't just types, it has to be within your project, right? It has to be in /source, and you've configured all of your like Webpack or whatever, like all those things. They know where your source code lives, and you can only import those things. But if you just import a type, you can say C:/ or whatever you might be using. And this add backend that I've specified here, this is just a like an alias that I've specified in my TypeScript configuration, because, well, I'll get back to why we're doing this, but it could just say /server/source/ whatever. Yes.
So in the client, you use the same exit type that you use in the back.
That's right. Yes.
Okay. I mean, it's not the magic is has kind of negative connotations sometimes. So it's not
fair. Yes. No, I think this is nice. It does feel like it's by accident that it works. I don't worry that the TypeScript people are going to disable this feature, because it does like it is clearly on purpose, but it does feel like, oh, okay, so because of this weird thing, we can make this work. But I think it's a nice way, because it means that I don't have to go and build my backend and have it output something that my front end then can read from somewhere. It's just the same. Yeah.
What if you write your backend in another language? Can it generate types then, or?
Not this library cannot.
Okay.
But you could make that if you feel so inclined. But yeah, then you would have to go through that step. And I don't know if there's anybody looking into that at the moment. But that definitely seems like it makes complete sense to me that would happen. And since this is a React talk, I should talk about React. So this is what we can do in React. So we were already using React Query, and probably I know that I spoke to some of you that are also using it, and I think that's an awesome library. So if you are not familiar with that, I can recommend that as an alternative to Redux or Recoil or whatever you're using for state management. React Query is basically just a thing that fetches stuff from your backend and then caches it. So it can sort of feels like, well, I just ask my backend anytime I need something, and then that takes care of caching. So it actually performs well, but instead of figuring out, oh, I get it from my backend and then I store it somewhere, and then I have it here for when I need it, and then I figure out when I need to get a new one. It's just a very nice way. And they've made well, I think it's just an instance of React Query that just has a little bit of specialization. So so basically you say use query, which is like a regular hook, and you specify whatever the name of the query is, and then you get these things out of here. There's a number of return values, and that's like if this is still loading, if it errored, if it's exceeded, and so on. And you can check, well, so the data will have the type. Well, I'm actually showing that here, but the data here will be the type that was the return value from the server. I can try and show you in my IDE. If I can make this. Maybe I need to do this. Well, actually, this is this is a plain vanilla consumer that I have here, so you can see. But I mean, I guess you have seen already what that means. But if I do something like this, you can see that it will return. Oh, this doesn't work. And if I go into my this was my this is the back end. So if I change something here, let me see if I can find that get profile route that I created there. This is the one we have here. If we said that this was actually called like so, and I would need to do this, and I save it. If I go to my front end thing here, there we go. So it needs to catch up a little bit, and but it does realize that this is not what it's called anymore. So yeah, this is what's nice about it, that it's so direct and ingrained. So the benefits of this to me is that this feels like how it should be with type safety. Like I don't understand why we have to have all these JSON descriptions and stuff, like when basically what I want to do is I want to send some things to my server and I want to get some things back, and we have all these type systems. Why can't I just use one of them? And this feels like finally I can do something that feels closer to just writing a desktop app, which is like, well, this is how I want to do it. But it's not simpler than that, because what is tempting to do maybe for a number of people, and I personally worked at a company called Realm, where we were writing a database that would automatically synchronize between backend and front end. And I'm a huge fan of Realm, and they're very, very talented people. But I kind of think that's trying to take it a little bit too far, because it's trying to make it look simpler than what is possible, because that automatic synchronization doesn't always work, and then it's weird what you do then. But so I feel like this, it doesn't try to hide that there's network between it, and like you need to specify data that is serializable. You can't just send like some object that is connected to other things in your code, and it's quite easy to see that that would break because you are specifying this is a query and it can only take strings and numbers and so on. But still, that feels like the level where it should work. And also this works easily with our regular server, so to speak. So we have REST endpoints also running there, and it just combines very well with it. So we have a COA server, which is similar to Express. It's just a different version, and so we add this as middleware, and so it handles all the endpoints that are /tRPC, and then we have some webhooks and authentication and stuff that goes to other places, and that just works very well together. We do have a bunch of challenges as well, though. First of all, in Miami, we don't have a monorepo. I have that in Submotion, and I really want us to move towards a monorepo in Miami. But you can probably very quickly guess what the problem is there then, which is that when our front end checks out on CI, it doesn't have the back end and all those types that it needs. So we can't currently do this type checking in our CI, which obviously is losing a lot of the value for us. So this is why I have that alias that I showed you, where we say /add backend /something, because we're actually replacing that on our CI server So it's a different thing, and that's annoying. But yeah, that's the best we can do now. Everybody, all the developers will have the type checking on their local environment. So, and since you get these red squiggly lines immediately when you do something wrong, I feel like it's probably not that dangerous, but it's definitely something we need to fix. And speaking of testing, it's the website, and it seems like the official thing that the CAT is suggesting is just to use Playwright, which is like a browser remote control thing. So to do very end-to-end tests, and that's certainly great. I am a big fan of end-to-end tests. They're the most thorough tests you can get on, but they are also not very good for like unit tests and integration tests are necessary if you have a large sample space. If you have a function that takes in a combination of parameters where you want to try out a bunch of those combinations, if you have to go through a whole thing where you log in and all that first, that's just silly. So I don't think that should be the only way to test things. And so we've written two sort of mini libraries that I think we'll probably make open source if he doesn't come up with something, but that can plug in on either side. So on the server, it can act like a little client, pretend to be a client that makes requests and so on. And on the client, it can pretend to be a server that you mock return values. And so it's very obvious and simple, but it was code that we had to write, and it's home written, so to speak. It's like, it's not very complete yet. So that was something. There's also the thing with these types that we're sending back and forth. There's still a transport layer, even though it looks like we can just call a function now. But for instance, we're making calls to Stripe, the payment system, and that has a bunch of TypeScript types. And so attempting to send some of those, like put those things into the response and just pass that along. And we haven't figured out yet whether that's a good idea or not. It seems to me like it isn't, but I can't articulate why. So it's just this feeling I have. Like, it seems like we should be the ones specifying what's in there, but I'm not sure exactly why I think that. So maybe I'm wrong, but yeah. There's also the problem with refreshing tokens. We used to just have an instance of Axios, which makes just an HTTP request. And there we could just interject if the request would return with a 401, then we could put it into a queue and make a request for refreshing the token, and then that would all work. But tRPC doesn't have any infrastructure for that. There's no place where you can plug in something like that. So now we have a little poll thing that runs in the background and refreshes our token, which feels also a little bit silly, but it works. And then the last thing is that we're using this Koa server, which is a bit unorthodox. So that's probably just a challenge for us, but that we had to write our own middleware to use it with that, and that may have a bug or two, but I don't know. I think that's what I had to say. So I'll take questions now. Yeah.
First, I want to say about the Stripe. From my experience with Stripe, they have great customer support, so you can just text them and they're going to straight to ask the developers, and maybe they know something that will answer.
Yeah.
And my second question is, like, there has been some time since I read about like remote procedural calls.
Yeah.
And what I remember is that when I was reading, I thought to myself, I'm going to forget everything after a week. And yeah, I forgot everything. But my question is, like, how close is like tRPC to the Google's version, gRPC?
Yeah, so I think that so the way he's encoding things underneath, I think is sharing a part of that protocol. But we're really in territory where I don't know it. So it's very easy to look at. If you look at it in the web inspector, it's all just JSON. But what the exact encoding is, I can't speak to that. So, and I haven't used gRPC. So yeah.
How complex types can you make in this, like for return arguments? Can you make like too many unions?
Yeah, I think you can do anything that TypeScript allows you to. So the only question to ask yourself is if this feels like a smart thing to send over the network where you serialize everything. But yeah, I do like a discriminated union or something would make perfect sense, and that you can easily do. So if you're using Zod for the validation, which we are, then you are limited by what you can express with Zod. But you don't have to do that. You can add as an input validator any function that will take something and return something, and where the type can be inferred. So yeah.
Is tRPC addressing the caching problem other way except for the
No.
get requests?
No, that's it. So
aware of any plans of having something like for data
oh,
structures?
actually, no, actually, this, yeah. So there's one thing that that I need to say is that it supports batching out of the box.
Yeah.
So you can tell it to batch, and I must admit here that I'm not completely clear on when and how it does it, but it clearly can do that. So you make a bunch of requests, and it assembles them into one that it sends to the server, and that. So it does have support for that.
That's good.
Yeah.
Yeah.
Yeah, no, and that's what I mean with that. It seems rather mature for it because it's a young library for sure, and it's one guy effort so far, more or less. So it's obviously a gamble that we made, and yeah, I know that one thing that he says is a potential problem is if you have a lot of endpoints, then the TypeScript compiler might start getting slow doing all this inference, and you need to figure out if that's something you can live with, because that is build time, and that can be a problem. Yeah.
So you just mentioned that you took a risk when choosing tRPC. Like,
yeah.
Did you think about a backup plan?
Run. I felt like it wasn't that risky because we could plug it into our core server where we could easily write REST endpoints as well. But if we discover problems after we've been implementing this for 4 months, then that will already be annoying, and after a year it would be a problem. So yeah, that's a gamble I've made. So we'll see how it evolves. Yeah.
So I remember from your last talk, you were presenting this thing called Kenny.
Yes.
Are you using that in conjunction with this? And could you maybe say a small word about it as well?
Yeah. So we are using that. So Caneel is an open source project that I talked about at that previous talk, which is where I launched it, if you will. So it's a project that looks at a Postgres database and generates TypeScript types from the tables, basically. So it's a way, it's sort of a reverse ORM, or it's a way to keep your types consistent from the database down to the backend. And now using this, we can actually, so we do use types generated by Caneel for a user or something, which comes directly from a database table, and we pass that all the way to the front end. So now it really is from database to front end type safety, which makes me happy. I think that's pretty cool.
I can say we have also used it in production as well.
I'm very happy to hear that. Yeah. Yes.
I just want to hear another good way to kind of do this kind of nested resolver functions in the server side. So basically you say this is how I get a user, and then in other resolver functions you say I should return a user if it's requested, and then
right.
It's the same function.
I don't think I know of anything specific for that, but obviously you can write your functions and everything is plain Node, but yeah, it's I don't think that I know of anything like that. So one thing that you wasn't maybe clear was that you can nest routes. So you can say this is profile dot and then something dot something, and you can create those specific endpoints under that. But yeah, it's sort of related. If I can just quickly, like everybody else, say that obviously we're hiring. So if anybody wants to come and work with me on this, then please do reach out. And otherwise, if you're interested in what else I'm doing, like KristianDupont.com on my links. I think that probably concludes it.
Thanks. So that concludes the planning talks. We still have some time here, and we have this concept of an open stage. So if there's anything you would like to show to people, please come up. We'll start with that in 5 minutes. Otherwise, feel free to socialize as well. And I think we have to leave here at